Hi class, in this video we're going to talk about independent and dependent events. So as you guys know, I love writing down the rules. So this is the rule we're talking about. Events are independent if the occurrence of one event has no impact on the occurrence of the other event or events. So the example I like to use in class is rolling a dice. So if I have a die, and I might just make some videos of me rolling a die, but if I have a die and I roll the die, or roll the dice, and it comes up, and let's just say the number 5 comes up when I roll the dice. Now, if I'm going to roll the dice again for the second time, do you think that me rolling a 5 the first time has any bearing on me rolling a dice? I mean, rolling a dice and and getting a 5 the second time? No, it does not. So we know that those two events are independent. Same thing if I were to flip a coin, and most people don't realize that but the same thing happens if I were to go to Las Vegas and I pull the lever on the machine. Me getting, if I'm playing Lucky 7, me getting, 1, 3, 5 the first time has no bearing on me getting 1, 3, 5 again the second time, right? So these are independent events. And so the example given in the book is, and this is kind of like a introduction to what we call conditional probabilities. So the condition A or condition B happening given condition A or vice versa, we're going to look at what happens in these particular situations. So the example given in the book, I think they're playing, I want to say they're playing golf. Maybe they're playing tennis. I can't quite remember. But we're talking about the warm-up period between Bob and Deb, his wife. Bob is the author of the book, and Deb is his wife. So they have a short warm-up time versus a long warm-up time. And we're saying that Deb winning, probability of Deb winning is A. Probability of having a long warm-up time is B. So we're looking at the probability of Deb winning given that she had a long warm-up time, right? So he's saying he thinks that there is a correlation, right, between her having a long warm-up time and her winning. And we're trying to see if these two things are independent or dependent. So given, I've written this formula, right? I try to take a couple shortcuts. What's the probability of Deb winning given she has a long warm-up time? Well, we know these two things are independent if the probability of A given B is equal to the probability of A. So the probability of Deb winning given that she has a long warm-up time, if that is the same as the probability of her winning, then we know that these two events are independent, right? So let's test it out and see how this goes. So we know that the probability of A, right, is equal to the probability of Deb winning is equal to 11 out of 25. And we know the probability of having a long warm-up time, right, is going to be 10 out of 25. So this is a long warm-up time, and then this is the probability of Deb winning, right? So, and we know that the probability formula is given in the book, the tongue is the probability of A given B is equal to the probability of A and B, right, over the probability of B, right? So we know the probability, in this particular situation, the probability of A and B, probability of Deb winning and having a long warm-up time is probability of A and B is equal to 7 over 25, because that is the intersection. So given this formula, right, this would be equal to the probability of A and B, 7 over 25, divided by, let's do it this way, divided by 10 over 25, right? And we know just doing math is 7 over 25 divided by 10 over 25 is really equal to, take the reciprocal, right? And that is equal to 7 out of 10. So the probability of A given B is equal to the 7 out of 10, right? Which is not equal to the probability of A, which is 11 or 25. So these events are not independent. So there is some dependency between having a long warm-up time and Deb winning. All right, so this is in your textbook under the section of independent events. Let me know if you have any questions.